DNA digital data storage. In our data-driven society, the accelerating growth of digital information is stretching traditional storage technologies to their limits. Existing solutions struggle to keep up with the rising demand for more efficient, durable, and capacious storage. What if we told you there's something which is beyond your imagination? Welcome to the new era of technology, which could transform data storage as we know it. The new era of DNA, digital data storage, where only 1 gram of our DNA can store 215 petabytes of information. A petabyte is 1024 gigabytes, thousands of megabytes. Thus, 1 gram of DNA can store approximately 221,160 genetic instructions. By the end of this video, you will have covered the mysteries surrounding how our DNA can serve as the ultimate data repository, storing vast quantities of information. Let's start the journey. What is exactly DNA digital data storage? DNA digital data storage is a method for storing digital information within the DNA molecule. Imagine converting all the ones and zeros in your files into DNA code letters. It's similar to placing data in microscopic, potent capsules. This innovative concept is at the forefront of 21st century technology, along with quantum computation and other astounding developments. DNA is incredibly small, but it can store an enormous quantity of information and is extremely stable over time. Recent years have witnessed an astounding expansion of the digital universe, fueled by our growing reliance on technology. As our dependence on digital data for various aspects of life has increased, so has the demand for efficient and sustainable data storage solutions. Conventional silicon-based storage devices, such as hard drives and solid-state drives, have served us well, but they have inherent limitations that inhibit their skill and long-term viability. Nevertheless, the technology sector is on the cusp of a revolutionary transformation as it embraces the revolutionary profundity of DNA data storage. Quantities of information. Imagine the potential of storing entire libraries, archives, and vast datasets in a single molecule of liquid DNA. It can store an astronomical quantity of data in an infinitesimal amount of space, making it the ideal solution for our continually expanding digital requirements. How does it actually function? What can it accomplish? DNA uses 4 letters: adenine, A, thymine, T, cytosine, C, and guanine, as opposed to the ones and zeros used by conventional computers. Consequently, scientists convert the zeros and ones into these DNA letters and construct new DNA molecules using the information, as if they were composing a secret message in a genetic code. DNA, which stands for deoxyribonucleic acid, is a molecule that contains the genetic instructions for all living organisms. It is a space-saving method of displaying information that is extremely effective. 1 gram of DNA can store an astounding quantity of information, as much as 215 petabytes. That is equivalent to storing millions of 4K movies on a particle of salt. DNA data storage eliminates the problems associated with digital information storage. DNA data storage is an intriguing solution that addresses 3 significant issues with digital information storage: the capacity, dimensions, and durability of storage hardware. We frequently struggle to store massive amounts of data in a manner that facilitates later retrieval. Also, the physical space for storage hardware is a challenge, not to mention how long the hardware lasts. But here's the interesting thing about DNA data storage: it does not require any physical space. It can store enormous quantities of data in extremely small spaces. One can compress nearly limitless information into a small amount of DNA. Currently, DNA data storage is still in its infancy. DNA can be manipulated and constructed by scientists, but the concept of using DNA to store digital data is still being investigated. Scientists are still determining its optimal application. However, the potential is mind-boggling. We may one day store all of our digital data in the smallest and most potent DNA molecules. How amazing is that? How it may be utilized. A DNA data storage could revolutionize the preservation of large-scale data archives, such as libraries, historical documents, and scientific databases. It can preserve for future generations cultural heritage, art, music, and literature. This would ensure that human knowledge and accomplishments are preserved for centuries to come. Additionally, it can be used to store email and photos and other digital files. Currently, our planet contains approximately 10 quintillion gigabytes of digital data, and humans generate an additional 2,500,000 gigabytes of data every day. To manage all of this data, we rely on exabyte-scale data centers. Exabyte is equal to 1 billion gigabytes, which can be as large as 4 football fields and costs approximately $1 billion to maintain. The benefits of DNA data storage. DNA data storage has numerous benefits, including a large capacity for storage. The greatest advantage of DNA storage is its tremendous storage density in comparison to other storage methods. When data is stored in the cloud or a NAS, it is still sent to enormous servers and data centers. Some are as large as football stadiums and are extremely costly to construct and maintain. With DNA data storage, however, it is possible to store vast quantities of data in a small space. This means that you will not encounter storage space issues or run out of storage equipment. It is comparable to squeezing a vast library into a tiny capsule. Therefore, DNA data storage provides a highly efficient and hassle-free method for storing massive amounts of data. Durability is the second most important factor to consider. DNA data storage is the undisputed champion of long-lasting logs. Unlike conventional storage methods that can degrade and become obsolete, This method keeps your data secure for the foreseeable future. This durability makes DNA data storage ideal for preserving crucial historical documents, cultural artifacts, and scientific information. Imagine passing on valuable knowledge and discoveries to our great-great-great-great-great-grandchildren and beyond. DNA data storage is a time capsule for our most valuable information, ensuring that it remains accessible and secure for a very long time. DNA data storage has the unique advantage of replicatability. Regular data centers must copy and transfer data to new hardware frequently to ensure its security. With DNA data storage, replicating data is an ease. The scientists have discovered a clever ploy. The DNA containing the encoded information is inserted into a bacterium. The bacteria then duplicates itself, transmitting the same information to the next generation of bacteria without error or loss. It's as if DNA data storage has its built-in copy mechanism. This is a fantastic solution for preserving our data without the hassle of constant transfers due to its simple duplicability. DNA data storage is capable of long-term data preservation. The fourth priority is environmental sustainability. DNA data storage is an environmental triumph. Evidently, conventional storage methods necessitate a great deal of energy for refrigeration and maintenance, which is harmful to the environment, whereas DNA data storage is much more eco-friendly. DNA requires significantly less energy to retain and retrieve information. In addition, the physical space required for DNA storage is minuscule compared to the massive data centers we use today. We can save vast amounts of energy and reduce the amount of space required. This is excellent news for the environment. DNA-based data storing is similar to turning green in the tech industry. It is a significant step towards making our digital world more sustainable and leaving a reduced environmental footprint. What are the limitations of storing DNA data? DNA data storage has some limitations that must be addressed before it becomes a widely adopted solution, despite its enormous potential. A significant disadvantage is the price. Currently, DNA storage is considerably more expensive than traditional storage methods such as hard drives or the cloud. Creating and storing DNA molecules, in addition to reading and decoding the data, can be quite expensive for many organizations. For example, storing 1 foot of data using DNA synthesis and sequencing technologies could be prohibitively expensive. $1 trillion. As predicted in a 2021 The Massachusetts Institute of Technology, MIT, has issued a report. The exorbitant cost of synthesizing and sequencing DNA continues to be a major challenge. Despite the fact that technological advancements are anticipated to eventually result in cost savings, the decreased pace of DNA data storage compared to conventional methods is another significant disadvantage. In today's fast-paced world, data retrieval speed is crucial for many applications. Encoding and decoding data in DNA is presently a sluggish process. Synthesizing the A strands and encoding the data onto them one nucleotide at a time is required for writing data to DNA. This may require several hours or days, thereby rendering it impractical for situations requiring quick data storage. The overall sluggish pace of data encoding and decoding in DNA makes it unsuitable for situations requiring real-time data access and retrieval. The next generation of DNA data storage Many experts believe that DNA data storage is the storage technology of the future. Biotechnology is promising, and gene sequencing has made it a viable option for large-scale data storage. The successful storage of data in DNA has been the subject of research since the late 20th century, with significant milestones achieved over time. The DNA fountain method demonstrated the theoretical optimum for per-nucleotide information storage. Later, researchers from Columbia University encoded a computer operating system, a movie, and other files totaling 2.14 by 106 bytes in brief DNA molecules using a Sudoku-like encoding scheme. By encoding data into yeast cells, it was possible to achieve a density of nearly 432.2 EB per gram of DNA, which is close to the utmost density possible. Thanks for watching. Please subscribe and hit the like button.